Hello, my name is Peter Hessler. I'm with OpenBSD, and I work for a company called HostServer in Germany, who has graciously sponsored a lot of the work I've been doing on this project. So, with a lot of networks have a problem with spam, and there are a couple ways that you can deal with this. You can look at the content, and you can deal with it at the network level. I'm mostly focused on dealing with this at the network level. The traditional methods are that you can download a list of IP addresses you want to block from a website, or you can do a DNS lookup from an external provider to try and get access to who you want to block. This has a couple serious problems. When you download it from a website, then everyone usually downloads it on a periodic and a cron job. And it is only as fresh as when you download the file. So if you download it at the top of the hour, but then a spammer address is added at 2 minutes after the hour, then you have to wait until your next refresh for this. The other problem is that since everyone downloads it at the top of the hour, then at 58 minutes, the server is not doing anything. 59 minutes, the server is not doing anything. Top of the hour, the server is screaming because now it's completely congested with all the requests coming in. At 1 minute and 2 minutes after, then everything is finally loaded, and then it's quiet again. You also have the problem of the network bogons. As I'm sure many of you remember, bogon lists used to be passed around and would be manually installed into a router, but then eventually those networks actually got allocated and assigned, but if you still had those lists, still had those block lists in your router ACLs, then you couldn't connect to that, to those networks. And if you do an external lookup, then your ability to receive email is dependent on their speed. Many years ago, there was the big attack on Spamhaus with a huge DDoS, which shut them down. The problems that were seen ranged anywhere from email was delayed until Spamhaus came back up. Email was delayed by a few minutes while they tried and then failed and then just gave up. And then actually a few providers even just said, oh, all email's invalid because Spamhaus is gone. And so a lot of email was dropped at that point, which is clearly a problem. So what I'm doing instead is I am combining the two methods of having local storage and automatic updates. So I am taking in the whitelist and blacklists that you find from a gray listing service and then distributing them into BGP. And this utilizes basically the combination of a host route can be described as a network. We have BGP communities to label each of them, whether they're a trap or a bypass or whatever. And that in the software-based BGP implementations, you can also tell it to not install the routes into your routing table. So what we're trying to do is only the IPs that exist a very specific behavior. We don't want to reward or penalize any of their neighbors. It's very common that, like in a shared hosting environment, for example, someone will send an email that may be marked as spam, but then you also have something in the shared hosting environment, and then you're being punished for this, and that's not acceptable. Conversely, if you are sending a lot of mail and it's all very legit, and you get added to a whitelist, why should your neighbor who is not you, who is not involved with you in any way, be rewarded for this behavior? This technique also works very well with gray listing. And so gray listing, for those of you who are not familiar, is basically a method where you try to send an email, the email server says, I don't know who you are, try again later, temporary failure. And then eventually they retry enough and they get through. Many spammers simply don't retry at all. It takes a little bit of their resources and they can't blast out the emails as much as they could. Large providers typically see like 90% drop in spam that gets through to their content scanners simply by turning on gray listing. So it's good to use the bypass and the whitelist filters and the trap lists, the blacklists from other parties. Normally when I give this talk, it's to people running smaller sysadmin networks. And so ordinarily the other sources are larger than them. In your case, maybe not so much. I'm not sure anyone has more email going through their network than possibly Gmail. But they also have different traffic patterns. If you focus mostly on a consumer market, you will have very different emails than people who focus on a commercial business side or for students or whatever. And if they're in different regions of the world, you also want to share that information. Spammers usually hit everyone in the world, whereas the whitelist generally region-specific or at least industry-specific. As part of this, as I mentioned with gray listing, you need to retry sending the email. And by retrying the email, you have to connect from the same IP address again. Gmail has a famous problem where when they retry an email, they'll be from any random IP address that they own. They own quite a few IP addresses. And the problem, so generally it's within the same /24 for IPv4, which is okay, but in IPv6, it can be anywhere in the same /64, which is ridiculous. And so trying to whitelist entire blocks of /64s on IPv6 will make it, is definitely problematic, especially as more shared hosting gets into IPv6, and then you now have suddenly hundreds of thousands of systems within the same /64, as opposed to before, where you only had a maximum of 255. So that was, in the v4 era, that was much easier to deal with, much easier to work with. So I've been running a implementation of this, and it's all available at bgp-spamd.net. I have open sourced pretty much everything. I think I just have one configuration file I need to upload still. If you like what you see and you want to participate, please talk to me. Using it is available for free and is available right now. I publicly launched this in 2013 at a conference called AsiaBSDCon. Originally I had three sources and 4 users on the first day. And then you can see here I grew quite a bit. When I wrote the slides, 5 upstream sources, 134 users, and I have 2 route servers. I have one in the US and one in Europe. So what are these? You get the trap list. And a trap list is basically their poisoned email addresses set up so that way any emails to them will be marked as bad because they are just hidden on a web page somewhere and they're have never been used for legit purposes. And so with gray listing, you have the first attempt come in, and so you know nothing about this server. You don't know if they're good or bad. If their first attempt to email you is to one of these trapped addresses, it's added to a blacklist. And this is what's distributed within the network. They're blacklisted for 24 hours from the last delivery attempt. So if they keep trying, then they keep being blacklisted. Then the trap list is your traditional blacklist that you find on a lot of different places. OpenBSD publishes one on their website. Hessler.de publishes them. You get them from a variety of sources. This is the normal trap list that you would find in most places. I also have the bypass list for some of these sites. So as I mentioned with gray listing, is you need to try again to connect and then eventually get added to a whitelist. Sharing the whitelist is very beneficial because then you don't have to do all the work for them. And again, with Gmail, if you don't have a huge amount of traffic coming in from Gmail, then you're going to have a lot of extremely delayed emails from Google and from people using the Gmail system. Other free hosting providers also do this. Hotmail has a similar problem as well. Most of the larger ones do. And so you want them to retry, and so you'd want to utilize this to help avoid part of the gray listing problem on your own site. But getting added to the implementation, the original implementation of SpamD's local whitelist is really easy. All you need to do is retry within the first 4 hours. Just retry once, and then you're on the whitelist. And then you stay on the whitelist for just over 36 days. And so that is way too open for us to redistribute to others. We can't tell what the health is for that. So for now, we've decided arbitrarily to do, if it's in the whitelist for 75 days and they've sent more than 10 emails, we think it's a real server. Part of the thing we want to do is we want to avoid the problems of gray listing, but we also recognize that gray listing is incredibly powerful and is very useful when you can trust it. So to be redistributed, you need to spend a little bit more time and effort on that. So to start off as an experiment, I think it is a success. The people using it generally like it. This has both lowered the number of spam attempts they get and has increased the reliability of the first email from a server. Many sources are sharing the information, and so you can combine both the blacklist and the whitelists for both uses. Originally, this was all done purely in OpenBSD, and this was presented at a BSD conference, so there was a lot of OpenBSD people in the audience. My original examples were purely on OpenBSD and using OpenBGP for this. I had 2 different users submit that it worked with how to configure it with FreeBSD and another tool in Spam Assassin. Another person who wishes to remain nameless is using Quagga and their own internal infrastructure for spam. Thank you to them. It's relatively fast. And so, as I mentioned earlier, you have the problem of fetching these updates from a web server. It can take probably about an hour or so before they update their file. Once my sources add an IP address either to the blacklist or the whitelist, it propagates very quickly. It's well under 2 seconds to everyone, generally sub 1 second. And you can actually connect over your home DSL line or from anywhere you want. And even over a very bad home DSL, everything gets loaded in about 7 seconds. One of the problems we had, though, was that the criteria to get on the whitelist was way too easy. And so this is something that still needs to be adjusted. I've removed already the 2 main sources of them who they received just too many emails, and so they have a few 100,000 clients on their system. So their whitelist, unfortunately, is a little too wide open. We do need to spend more time working on the heuristics for this to make decisions, and so that way we can pass on their benefits. There was a server crash, which was definitely a problem. That caused about a 5-day outage. I was in New Zealand on holidays. New Zealand, as you may know, does not have the fastest internet possible. And it also happened during a long holiday weekend in the US, which is where the implementation was being hosted then. And that was the only option. So I had to email them and wait for them to come back from the holidays to restore the system. There's been, unfortunately, not a lot of time I've been able to dedicate to this. With my current job, I've been able to dedicate a lot more time to dealing with this problem and to being able to discuss and solve some of these issues. So future work that we still need to do is fix the heuristics for the whitelist and the bypass list. We definitely need to solve the Gmail sender problem. Possibly it's talking to people at Google. Possibly it's things that I can do on my side. I did a test with just a purely blank filter list and had my own Gmail account email me. And it took about 3 days before I finally just gave up and just whitelisted a whole huge chunk of Google. That's clearly is not a thing that you want to do. You want this to be automated. You want this to just magically work for you. It retried from, I believe, 400 different IPs and only had 2 retries from the same IP address during that time frame. So future work includes some easier processing. Right now, it's some ugly scripts and some very simple heuristics on this. We definitely can use a lot more sources. Right now, it's heavily based in Europe and Canada. And so this does not work out really well, for example, for Japanese audiences, because university students in Canada don't really send a lot of email to Japan. But this could solve problems for everyone all over. Some other interesting ideas are like possibly a voting mechanism. I'm not sure this can be done at all with what I'm utilizing. I recently had a thought about abusing an RPKI lookup of when someone tries to add an address to me, then I do some external processing and then decide, oh, it's a valid RPKI signature, so I'll allow it or disallow it based on that. So it's something to investigate for us. I've had a lot of people assist me. Bob Beck from the OpenBSD project helped me write the original paper. I am getting data from the University of Alberta, from Bob Beck, from Henning Brauer, who runs a hosting provider in Germany, from Peter Hanstein, who also wrote the book of PF for OpenBSD. He also does quite a bit of work on discussing spammer attacks. My original implementation is being hosted by Sonic in California, USA, which I'm very grateful to them for. And my current company, Host Server, is hosting the European mirror and is also sponsoring some of my work on this. So, are there any questions?
Okay, no questions? Okay, thank you very much, Peter.
Thank you.